Okay, so the 35th problem in the lead code is the search insert position. Okay, so basically here we'll be given a list of numbers, distinct numbers, and they're already sorted. Okay, and also we'll be given a target. Okay, the first thing is we'll have to find if the target exists in this array or not. Okay, so if it is found, we'll have to return the two. Like, I mean, we'll have to return the index of it, or else what we'll have to return is we'll have to say possible search insert position. Okay, and we know it is a sorted order, correct? We need to, it is a sorted order, and let's say that this 5 was missing. Okay, let's take the example 2. Okay, 1356, and given target is 2. First, let's say that if is it here, like, I mean, 2 is 2 present in this list? No, right? Where it can go, like, and we know it's a sorted order, so where it can go and which index it can go, right? So obviously, like, we know that by looking at it, we can say that it will go here, correct? So the solution would be, like, I mean, 2 should come here, so we should have to return the index of it, that will be the 1. Similarly here we need to insert 7, it seems. So obviously when we want to sort it, this is already sorted. Okay, and 7 would be coming at the end, right? So this is the problem about, and also we are given the restriction that we need to solve it in the time complexity of O of log n. Okay, so we cannot be using, like, I mean, with for loops and just check and insert it, right? Like, we cannot do that. We should be doing it when O of log n. Okay, so some of the points to be noted here is, we know that this list is sorted, correct? When we say, and also this is sorted, and also it is being asked that to search for an element, correct? When it is sorted and when we want to search, obviously we can go for a binary search here, correct? So as it is sorted, we can apply binary search here, and we can do a searching, and we can identify the index of an element, correct? We can identify an index of an element. That is one thing. Okay, and let's say that if it is not found, right? If it is not found, what to do, correct? It is exactly, like, I mean, what is being written here, right? It is completely the same as the binary search. Okay, like, I mean, the same exact same algorithm. But one thing to note here is, like, I mean, let's say that we want to find where to insert 2, right? So our left index will be holding that position basically. So let's say that when we try to search for an element, right, in the binary search algorithm, we are trying to narrow it down, right? Let's say we'll be having some tens or hundreds of elements in the list. We'll be shorting it down to the half of the list, right? And we'll be narrowing it down as much as possible, correct? At the end, how it would look, if we try to solve this, right? 1356, our mid element will be this, correct? And right, our left, right, and mid element will be 3. After doing our calculation, we know that 2 falls between this, so we'll be updating our left and right pointer, and it will become like left also here, and right will be also here, correct? We narrow it down such a way that the possibly the number could have been here, correct? Like, I mean, the last possibility, correct? When the left is equal to right, it means that that could be, like, I mean, that is the last possible thing that could happen, right? 2 is not here, obviously, right? When we increment the left pointer for the last time, our condition will, this condition will break, correct? Left will be not be equal to right, it will be, left will be greater than right, correct? Where in that condition, what will happen is, we already narrow it down to one position. Okay, but it is not there. Obviously the next index will be the search the next position, right? Let's say that if I want to insert any number, I tried looking for it using a binary search, and we reached the end of it, right? Like, left is equal to right, we still couldn't find it. Okay, we still couldn't find it. It means that we are already narrowed it down. The index is 0. Just after incrementing it, we will get the next insert position. Okay, that is the logic here, and we don't have to explicitly increment the left. Obviously in the loop iteration we will be doing it, correct? We'll be incrementing our left node, and such that at the end, the search to insert position, like, I mean, there will be searching it, and we'll be getting that index where to insert that given target. Yeah, that's it. Yeah, thank you.